We're going to continue in this lesson with trigonometry, and this time we're going to learn about using trigonometric ratios. Now, we've previously met trigonometric ratios when we studied right-angled trigonometry, probably back in second or third year. Now, for this first triangle shown here, we can see that we've got the hypotenuse that is opposite the right angle. The side that we call the opposite, that's opposite the angle. And the adjacent, if we come to this second triangle, the adjacent is the other side. It's the side that is next to the angle, because adjacent means next to. Okay, so for the first triangle shown there, we have the ratio sine x equals opposite over hypotenuse. For the second triangle, the cosine of the angle is equal to the adjacent over the hypotenuse. And for the third one, the tangent of the angle is equal to the opposite over the adjacent. Now, if we're given one of these ratios, we're then able to find both of the other ratios because we can find the unknown length using Pythagoras' theorem, and then we're able to state the other ratios. So let's see what that really means. Okay, so if we know that tan p is equal to 7/24, state the value of sine p and cos p. So we know that tan p is 7/24, but we also know that the tangent of an angle is equal to the opposite over the adjacent. Like so. So we draw a right angled triangle and we can put in our angle and label our triangle from there. So we've got the hypotenuse across from the right angle, the opposite across from the angle, and the other side is the adjacent next to the angle. And we know that it's opposite over adjacent, so that's 7/24, and we can label those two sides. Now for the hypotenuse, we can then use Pythagoras' theorem to find that side. So it's the square root of 7 squared plus 24 squared, and that gives us, in this case, the square root of 625, which is 25. So I can then state the value of sine p. Now sine p is the opposite over the hypotenuse, and that's 7/25. And the cosine of p, that's the adjacent over the hypotenuse, and that's 24/25. So that's example 1, folks. Just now would be a good time to pause the video and take this down in your notes. Okay, welcome back, folks, and we'll look at example 2 this time. Acute angles P and Q are such that sine P is equal to 4/5 and cos Q is equal to 12/13. We want to show that sine P plus Q is equal to 63/65. So firstly, sine P plus Q, well, we need to expand that. So that's the same as sine P cos Q plus cos P sine Q. Now, at the moment, I know what sine P is, that's 4/5. And I know what cos Q is, that's 12/13. But cos P and sine Q, I don't know what those are yet. So I can't actually use that at the moment. So if I take what I already know, sine P being 4/5, I can draw my right angle triangle and label my sides. So I've got the hypotenuse across from the right angle, the opposite the angle, and the adjacent next to the angle. I know that for sine P, this is opposite over hypotenuse. So that's 4/5. To get my adjacent, then I will be doing the square root of 5 squared minus 4 squared, and that is equal to 3. And obviously you can see here this triangle is not drawn to scale. So I can now state the value of cos P. I know that cos P is the adjacent over the hypotenuse, and I can see from the lengths in my triangle that that is 3/5. Now, I also am told that cos Q is equal to 12/13. I can label my triangle. And I know that cos q is equal to the adjacent over the hypotenuse. So that's 12 over 13. To find the opposite, do 13 squared minus 12 squared and square root that. And that's equal to the square root of 25, which is 5. I'm then able to find the value of sine q. Sine q is the opposite over the hypotenuse, and that's 5 over 13. Now I can then go back to my expansion here. Sine p is 4/5, I already knew that. Cos q is 12/13, I already knew that. But the second part of this expression here, the second term here, I didn't know what these were, but I now do. So I'm adding 3/5 multiplied by 5/13. Now carrying out the multiplication, here I get 48/65 and 15/65. And adding gives me 63/65, which is what I was asked to show. So just now would be a good time to pause the video and take this example down in your notes before the screen goes blank and complete the assigned exercise for today.